Hello everyone, my name is Van Deary and this is my walkthrough for Lab 9. In this lab I implemented a server that communicates with three clients using non-blocking TCP sockets. Each client is serviced by its own receive thread, and incoming messages are stored in a multiplex protected message queue before beginning being displayed by the server. Here you can see that the project files are here, the makefile build, the server, along with the three client executables. The provided start and stop scripts are used to launch and terminate the clients. Project compiled successfully, producing the executable server, client 1, client 2, and client 3. And here you can see the main file. This main function, the server first creates a TCP socket, binds it to a local host using the port number supplied with the command line, and begins listening for incoming client connections. The listening socket is configured to be non-blocking, allowing the program to continue executing even if no clients are attempting to connect inside the main loop. The server accepts new clients, creates a receive thread for each one, checks the shared message queue for new messages, displays those messages, and sleeps for 1 second before repeating the process. Server is now running and listening on port 1153. The startup script launches three clients with a 1 second delay between each connection. The client immediately begins sending data to the server. Here we can see it's working. Here the server is receiving messages from three different clients, each receiving thread independently read data from its client and safely stores the messages in the shared queue. The main thread removes each message from the queue and prints it to the screen. And that stopped there. Safely pressing Control C causes the server to stop accepting new connections. Sends the quit command to every connected client. Reaches for each received thread to terminate. Closes all sockets and shuts down gracefully. This is the receive thread. Each connected client has its own receive thread, allowing the server to receive data from multiple clients simultaneously. The thread first configures a 5 second timeout using set socket op. If it then continuously waits for incoming data from its assigned client. Whenever data is received, the thread locks the mutex, places the message into the shared queue, unlocks the mutex, and continues waiting for more data. Near the top of the program, the shared message queue and mutex are declared. The receive thread uses this queue to store incoming messages, while the main thread removes and displays them. Because multiple threads access the same queue, a mutex is required to prevent race conditions and ensures the thread safe access. Once Control C is pressed, the signal handler changes the running flag to false, causing the main loop and ever received thread to exit. The server then sends the quit message to each connected client, waits for all received threads to finish using pthread join function, closes each client connection, closes the listening socket, and exits cleanly. And this concludes my walkthrough for Lab 9. Thank you for listening.